So the agenda for today, I will explain what WebSocket is, what it's used for, give you some idea on how it works, and then we'll spend the rest of the time on the API itself. So, first the problem, interactive website. Since years we are trying to, there's some kind of echo, we are trying to add interactivity to the web. The web by nature is a very basic protocol. I mean, HTTP is basically I have a browser that is doing a request on a server, and the server sends back a response, and that's it. So it's a stateless protocol. So it's kind of difficult to add interactivity on top of that. So to add interactivity, to add more real-time capabilities to the web, well, there has been some solutions, such as pooling. So the idea with pooling is that we have the client, so the web server, the web browser, that is doing at every 5 seconds, every 10 seconds, just do a request on the server to see if there is something new. And if there's something new, the server obviously push that information. It works in some case, but you have the last seat. It works in some case, but it also have issue. I mean, if you know that the frequency is around 5 seconds, you can easily design your services like that. But if sometimes you have an update every 5 seconds and then 2 hours later you have only updates every 2 hours, you still have to ping the server every 5 seconds. So from an efficiency point of view, it's not really good. Another solution is pooling, long polling. So the idea is that, so basically HTTP, we are doing a request and we get the response from the server. Well, it's nice if the server, so it got the connection, and the server, when it sends the response, keep the connection open. So that means that whenever it wants to, the server has now a channel to send back information to the client. It works, but from a resource point of view, it's also not a very efficient approach. And then there's Ajax, same approach. We just so these are just some kind of alternatives, some how to workarounds to add interactivity to the web. But all those solutions are not very efficient. They are not real time. They are very heavy in terms of resources on the backend side, because if the server needs to keep 200 connections open because it has 200 clients, it's obviously not efficient. So it's inefficient, it's wasteful, and it's complex. That's what is being solved with WebSocket. So the WebSocket, as I told you this morning, it's a standard that defines a TCP-based bidirectional full duplex messaging protocol. So full duplex, really the two ends of the communication can talk at the same time. One side of the communication doesn't have to wait that the other is done to start talking. It's TCP-based, and it's based on HTTP. So it leverages HTTP to do its protocol negotiation. It's a standard defined through the IETF, the Internet Engineering Task Force, and it's part of HTML5. So you can be sure that if you have an HTML5 browser, you have WebSocket support. And not only that, as I mentioned this morning, there is also a JavaScript API, which is defined by the W3C, and that API has also needs to be part of an HTML5 browser. So the question is, okay, it's nice to have a standard, it's nice that it's in HTML5 and so on, but can I use WebSocket today? So there is a website, caniuse.com, which basically tries to look at all the browser, and you can do query on specific HTML5 features to just check if it's supported by your browser. So if you go to caniuse.com/WebSocket, you will get that chart. If we zoom in, we see that basically all the modern web browsers today do support WebSocket. Even Internet Explorer. Yeah, worse than that. The 20 BlackBerry users are also WebSocket support in their browser. So really the only browser that doesn't support WebSocket today, Opera Mini, and Android browser. But I'm not sure Android browser is still used. I mean, if you look at Android today, it's basically Chrome for Android, and Chrome for Android has WebSocket support. So clearly, that's something you can count on. So JSR356, part of Java EE7, but you can obviously use it outside of Java EE7. So it's a Java API to define WebSocket on the client side and on the backend side. The client API is being considered for Java EC9. So maybe, well, it's a good idea to have WebSocket support in Java EC, so Java Standard Edition. And obviously, if we do that, it would have to be based on a standard. And it happens that we do have a standard now in Java to do that, so it would have to be based on that JSR. But again, it's just it's just being looked at, and we'll see if it will be part of Java EC9. That's something that has to be addressed within the GCP. So the JSR356 reference implementation is called Tyrus. It's developed in open source, so you can have access. You can see the source code of Tyrus. So that's the reference implementation, and obviously since Java E7 mandate to have WebSocket, Tyrus is part of Glassfish 4. So if you use Glassfish 4 today, you will have WebSocket support by default. Something I need to mention also is that WebSocket is part of the web profile. So you don't have to use the full Java profile to use WebSocket today. So what's the basic idea? Well, you will see that it's fairly easy, it's fairly simple. So we have a connection. So that's basically, we have a session, a connection between two endpoints. So a session represents the conversation between two endpoints. Those two endpoints, once we have the connection established, can exchange messages in a full duplex way. And what they will have to do, so what the endpoints will have to do, they will just have to react upon events that are being sent on that session. And at some point in time, the connection will be closed, either by one of the endpoints or because there is some issue on the network. So that's really the basic idea of WebSocket. So, establishing the connection. So on the client side, we have a WebSocket client. It can be a web browser, it can be a Java application. It doesn't really matter. It's, as soon as we're complying with the WebSocket standard, it will work the same way. So we do an uncheck over HTTP, and the server send back an uncheck response telling the client that, okay, he understands WebSocket and he knows what to do from now on. So the handshake is being done over HTTP 1.1. So we see that we are asking an upgrade. So we want this HTTP connection to be upgraded to, in this case, a WebSocket connection. So the client also sends this key, so a sec WebSocket key. This will be used by the server. So this is a response from the server. So it's HTTP 1.1, obviously. The HTTP code is 1.1, meaning that you agree to switch protocols. So the protocol will be switched to WebSocket. And the server sends back a sec WebSocket accept, which is basically a SHA-1 computed value based on the key that was sent by the client. So it's a one way to acknowledge that, okay, I know what the client wants to do, and I'm also understand exactly what you want to do. So it's basically an ACK, and now the connection will be agreed to a WebSocket connection. So from now on, we can do standard WebSocket messaging. Something which is important to mention is that it's always the client side that needs to start the connection. The server cannot start a connection. So we have the connection established. So we have a session between the two. So yeah, sorry, I'm going a little bit too far. So yes, some other concepts, endpoints, as the name says, an endpoint is basically one side of the connection. So on the client side, it can be a browser based on using the JavaScript API. It can also be a pure Java application using the JSR356 API or a JavaFX application. It can be any kind of application. It doesn't have to be JavaScript based or Java based. As long as you have WebSocket support in that specific language, it will work exactly the same way. And on the backend side, we have also obviously an endpoint. As I told you, it's the client that needs to initiate the connection. So a client will connect to a backend remote endpoint. a server endpoint can have obviously multiple remote endpoints. I mean, several clients can connect to the same endpoint. So we have seen how the connection is being established, so the handshake. So from now on, both sides of the connection can exchange messages. And they will have to react, well, they don't necessarily have to react. So they will basically decide, okay, I'm interested in that specific event and I will react upon that message, or I just want to ignore it. So the first event, once the connection is established, that is being sent, is the open message. Basically, it tells the two endpoints that there is a new connection established. So the server can decide to react on that event, the client can also decide to react on that event, or they just ignore that event. And from now on, obviously, they can start to exchange messages, both ways. So from now on, the server can push information to the client, and the client can also push information to the server side. Another type of event that might happen, something goes wrong for whatever reason. So in this case, my server side will get an error event. So I need to do something about that, or I just ignore that. It really depends what the error is. And at some point in time, one side of the connection will decide to close the connection. So at that point in time, a close event will be sent to the two endpoints. So you see that there is not a lot of events to manage. So, how to create WebSocket endpoints? As I told this morning, there are two approaches, using annotation or using a traditional programmatic approach. Sorry. So this is basically the example we saw this morning. So I will just quickly go over again to make sure. So this time it's an echo server. So it's a simple Java class. Nothing specific. The only thing I'm doing here is that I'm using that annotation, so the add server endpoint, to say that this class should be exposed by the web container as a WebSocket endpoint. Its URI will be echo. And the next thing I'm doing, I'm decorating that specific method with the on message annotation to specify what needs to be done whenever there is a new incoming messages. In that case, when there is a new incoming message coming in, what I'm doing here, I'm just taking that payload and I return back to the remote endpoint. So you see, it's fairly easy to understand. The same approach, using the programmatic approach, sorry, the same application using the programmatic approach. So what we are doing here, here we are using the add-on open message. So whenever there is a new connection, what we do, we attach a message handler. And this message handler will basically work whenever there is a new message coming in. So whenever there is a new message coming in, I take the payload, which is happen to be text-based. I need to send back the information to have the remote endpoint. So from the session, I do a get basic remote to have the corresponding remote endpoint, and I just send it the text payload I got. So that was the code for the backend side. This is the code for the client side, the Java code, not the JavaScript code. So again, a simple Java class, and I want to turn that in a WebSocket client endpoint. So what I do, I'm using the add client endpoint annotation to specify that this class will be a client WebSocket endpoint. And I'm decorating the init method, so that method will be invoked whenever there is a new connection. And whenever there is a new connection, what I do here, I'm taking the remote endpoint through the session object, and I just send the text hello you. And that's all I'm doing. Now, if you run that code as it is, it won't work, because we are not in the container. So we need to bootstrap that. And the bootstrapping code will come later on. This is the same, exactly the same code. So WebSocket client endpoint, and we just so whenever there is a new connection, we take the session. We want the remote endpoint, and we want to send it this string, Duke in this case. Again, if you deploy that, it won't work. You need to bootstrap that. How you can bootstrap that in a Java SE application? Where? Well, it's easy. You just need to have a WebSocket container. So that's the first line. So you can get a WebSocket container instance by invoking the container provider get WebSocket container. Then you specify the URI, so really where on the network your remote WebSocket endpoint is. In my case, it's on my localhost, 8080. This is not right, so just ignore it. And the URI is WebSocket. So whenever I connect through WebSocket using that URI, I will reach my remote server endpoint. And finally, what I need to do, I need to actually connect to it, specifying my client class, so the class that we have defined just before, using that URI. One thing you will notice is that WebSocket URL starts with WS. And WSS if we are doing WebSocket over TLS. So you see that even the bootstrapping code, well, it's fairly easy to write and to understand. Sorry. So, in terms of messaging, well, in the few examples we had until now, you saw that we have only exchanged a text-based payload. Obviously, we can also exchange a binary payload. We have two ways of working, synchronous and asynchronous. Well, when I say two types of payload, there is a third type of payload. So as a payload, we have text payload, we have binary payload, and there's also a specific ping-pong payload, which is more used to do testing. So for example, you want to test the latency of your WebSocket connection, you would typically use the ping-pong payload. So we have synchronous capabilities and asynchronous capabilities. Something to keep in mind is that there is no delivery guarantee. So if you send something using WebSocket, so you invoke a method to send something over a WebSocket connection, your method will return. It just means that the payload has been sent. It doesn't mean that the payload has been received on the other side of the connection. So that's something you have to keep in mind. So, how can we send messages? So, from the session object, we saw that earlier, we just need to have the remote endpoint. So from the session, we get the remote endpoint, and we can send a payload. In this case, we are sending a text payload. Something else is that, and here it's more a kind of trick, is that you can also use the @onMessage annotation to send some payload. It's basically a reply. So the @onMessage is basically whenever there is a new message coming in, but if you happen to return a payload, it will be sent back to the remote endpoint. So it's a shortcut that you can use in some case. You don't have to send something, you can reply on an incoming message with an outgoing payload. So these are the signature of the different methods you can use to send payload. So you see that we can send text, we can send binary, we can send text and a binary payload in fragment. So the idea is that you will chunk, well, it's not you, it's really the WebSocket implementation will chunk the payload in different fragments, and the other side will receive them as fragments. The last one is quite interesting. We can also send custom object, and I will explain later what this is used for and why it's useful. So, sending, now receiving messaging. So, receiving, again, two approach, using annotation or using the programmatic approach. Using annotation, we just have to react upon the at on message annotation. You see here that there is a difference in the signature between the two methods. This one has a boolean as last parameter. It basically means, well, when you are using this one, you can use the boolean to make sure that the payload you get is the last one. When you are when the payload is being framed, so send chunked first and send in different fragments, you use this one to make sure that the payload is the final one and that you finally have the complete payload that was sent by the remote endpoint. Programmatic approach, same approach, except that you have basically, you need to attach a message handler to do that. So those are the signature, the method you need to use whenever you need to receive something. And again, obviously we can send custom object, but we can also receive a custom object, obviously. Exactly the same, but using the handler. And obviously, once you define an handler, you need to attach it to your session. So that's something you should keep in mind. So sending Java object, it's basically the custom object. So if we are sending just Java primitive, the WebSocket implementation will just send that Java primitive using a text-based payload, and basically it will invoke the toString method of that specific primitive. So there's not a big deal there. What is nice is that you can also use the WebSocket implementation to send Java object directly. So you can send any type of Java object using WebSocket. You can send those objects either over text-based payload or binary payload. And for that, we'll have to write what we call an encoder. So an encoder basically takes a Java object and it marshals it to text payload or a binary payload, depending on the case. And obviously, at the other side, so the remote endpoint, it will need to have the corresponding decoder to make sure it can understand what is being sent. So encoders, decoders, that's something which is important, and it works over text or binary payload, and it's you who decide which one to use. So the different signature of encoders and decoders, so you see that we can encode binary, we can encode text, we can decode text, and we can obviously decode binary. Now, something which is also important to keep in mind is that the encoders have lifecycle method that you can use typically. So let's imagine that you have an encoder that needs to use some expensive resource to do its encoding. For example, it needs to fetch data from a database. So that's something which is expensive in terms of resources. So what will happen is that you can define the init method of the encoders. You can open the connection to the database and obviously kill the connection in the destroy method. And when the encoders will be invoked by the WebSocket implementation, this will automatically be done for you. So this is an example of, in this case, it's an encoder and a decoder for text payload. So there are three methods. Well, so this is basically the method that will be invoked when we need to encode something. So we want to encode the Java object to a text-based payload. On the other side of the remote endpoint will do the opposite. It wants to decode the text payload in a Java object. For the decoder, there is a method that needs to be implemented as well. It's the will decode. And that method basically gets the payload, and it's used by the decoder itself to check that, to make sure that it can actually decode the payload. So in this case, I'm not doing any test. I just assume that I can decode it. But obviously, in theory, my will decode method should do a little bit more. So if I can decode, my will decode method needs to return a true. Why this is useful? Well, you can attach different decoders to an endpoint. So basically what you will do, you will attach different decoders to an endpoint. The WebSocket implementation, whenever it gets a text payload, will invoke the first encoder and the will decode method of the first encoder. Of the first decoder, sorry. The first decoder will check, okay, I'm not able to decode that, I have no idea what it is, so it will return a false. The second decoder will be invoked, its will method will check the payload, he has no clue, he will return a false. And finally, the third decoder will be invoked, the will decode methods will get the payload, it understands the payload, so that means that it can decode the actual payload, it will return a true, and that's that specific decoder that will be invoked. So the will decode method is important. Exactly the same example, but for binary payload. Obviously, we would have to do a little bit more work to test. So the will decode method will have to do maybe more works to make sure that it can actually decode that binary payload. The decoding will probably also be a little bit more complex, and the encoding should also be a little bit more complex, obviously. But you can use the both. So either text payload or binary payload. So encoders and decoders, how you configure them. Here at the top of the slide, I've basically defined two decoders, so the foo class and the bar class, and two encoders, the base class and the force class. So if I want to attach them to my endpoint, I just need to, in my add server endpoint, to use the decoders parameter with the class of all the decoders I want to use, and the encoders I want to use. So, and the orders you attach them will be used to invoke them. So the first decoder will be invoked, its will decode methods will be invoked, it returns a false, the next one will be invoked, and so on. At the bottom of the slide, it's the same approach, but using the programmatic way. You see that, well, it's a little bit more. So what we are doing here, we are just defining two encoders, the foo class and the bar class, and we attach them to my endpoints. And here we have not only encoders, but also decoders defined. So you see that using the annotation approach is easier. So something else, configuration and session. So basic example, we have two clients, client A, client B, connected to my Java E7 application server. So we have two session between my client endpoint and my remote endpoint A, and the same client B connects to the remote endpoint B. Obviously, remote endpoint is a logical view. I mean, from the server, this is a remote endpoint. So we have two objects. We have the session object and we have the server endpoint config object that we can use to store information. And I will use that slide. So let's take our basic chat application. So we have John, which is connected on that endpoint, so endpoint G. So if we need to store information which are relevant just to that session, so meaning the session of John, well, it's a good idea to store that information within the session. So within the session, we have a map that we can use to store information which is relevant just to that session. Same for the connection with Sally, so we have the session S, and in there we'll just store information which is just relevant to the session of Sally. We have another object, the server endpoint config, which defines the configuration of those endpoints. We can use that to store information which is relevant really to all the endpoints. So typically here, if we would have a transcript of all the chats between all the endpoints, well, this is not relevant to just one session object, so it's maybe better idea to store it here. So again, we have a map that you can use to attach information, which is really relevant to the, I would say, the logical endpoint itself, not just one instance of the endpoint, which is actually connected to a remote endpoint. So, path mapping, that's something which is easy to understand, but well, you need to understand it, because that's most of the time when we have issue with WebSocket, it's because something is wrong in the path. So, from a technical point of view, when we deploy on the server side a WebSocket application, it's deployed within the web container as a WAR, so as a web application. So remember that whenever we're defining a server endpoint, we have to specify a URI. So that was chat, I believe, in my first sample. In this case, it's foo. But that endpoint will be deployed within a WAR. So the actual path will be made, obviously, of that URI, but also the web context of the WAR itself. So the path will be my web app / foo. And obviously, this is deployed over on an actual host. So the host name is obviously also part of the equation. So the final endpoint you would have to use to reach that endpoint, well, you would have to invoke ws / the host name, the web context of the WAR itself, and finally the URI. So that's something you have to keep in mind. And there are some obvious basic rules. There can be just one single URI for an endpoint. URI are case sensitive, so foo is not equal foo. And obviously you need to have unique URI for endpoints. If you have two URI with the same endpoints, you won't be able to use any of them. Something else which is also part of the path is template. If you have used JSRS, it's exactly the same idea. So in the URI, we can use template, level 1 template only. So by level 1 template, we mean we cannot use a regular expression, for example, in the template. So these are two examples. So travel and mode is my template. I can combine them. So travel mode is my first template and class is my second template. And obviously, I will be able from my code to get the value that are being passed through whenever there is a WebSocket client that is connected to that URI. So some examples. So if we take that one, travel and mode is a template. Travel mode is okay. Travel plane is okay. Travel only is not okay. And travel steam train is not okay because there is no way to do mapping between that template to that one. And yeah, template have also to be unique. So travel mode is okay alone, but travel within the same endpoint, travel mode and travel VIP, that won't work. So how you can get the information which is passed to the template. So in this case, my server endpoint is exposed at this URI. So travel mode is a template. So keep in mind that this is not the final URL of my endpoint. We need to take in consideration the hostname and the web context of the application. But whenever I have a client that is connecting there, I just need to use the add path param annotation on my open event to get back the result which is being sent. So here I say that, okay, the path param mode should be, well, the value which is passed in that path param should be put there in travel mode. And obviously it's just a simple string, so I do whatever I want afterwards. And obviously we are not limited to one single template. We can have several templates. And finally, so we have templates, but we also have query strings. So if you look at this URL, master3.com/travel, plane, and then question mark destination equals Hawaii. So from the outside, there is no way to know if there is a template in there. You don't know. Maybe this is the web context, and this is just the URI, or this is the context is root, and this is a template, or we don't know. But anyway, what's important here is that there is a destination, and obviously we are able to get that information from our code. So if on the session object we do a get request parameter maps, we'll have access to all the parameters which has been passed in the query string, and we can obviously work on them. So you have the path parameters, you have the query string. Now something you have to keep in mind is that those parameters are they are not static, but they are basically just passed whenever there is a new connection. So as soon as the connection is open, you can get them, but there is no way for the client to update them. So you can use those mechanisms on the backend side to pass information, but obviously if you need to pass information in a more dynamic nature, you will have to handle that at the protocol level itself. So something I didn't mention, you see that basically WebSocket is an efficient way to send information both ways, either text or binary-based information. But obviously what you will have to do is you will have to implement your own protocol based on that. So a protocol which would fit your needs, I mean a protocol which will match your the domain of your applications. So typically, if you have a travel applications, you will have to define some kind of protocol that allows the client to book requests, travel requests, and those kind of things. So that's something you will have to do by yourself, obviously. Very quickly, security is basically leveraging the security we have in the web container. So we can have authorization, we can have authentication, we can secure the connection itself by using TLS, and so on. And there is also obviously a way to have at runtime to have some visibility on the security context. So we can know if we are over a secure connection, we can also get information about the user and so on. Endpoint configuration. Well, you would use that to configure the endpoint, to store information about the endpoint, but you can also do more advanced stuff. So, for example, you can modify the uncheck responses, those kind of things. But it's clearly not something you would do at the beginning. So wrap up. That will give me some time to do a quick demo. So we saw the concept of WebSocket. We have a session that represents conversation between two endpoints. Those endpoints will get events that they will have to react upon. We saw the life cycle, so there are a few events that will be generated on open, on message, on error, on close. JSR356, the Java API for WebSocket, two ways to use it. So it's a Java API that you can use on the client side, but also on the backend side. There is the easy way, the annotation-based approach, and there is also the programmatic approach, which is not that difficult, but it's a little bit more work than using annotation. So this is the annotation that you will use at server endpoint, at client endpoint, to turn a class in a WebSocket endpoint. Then the event you will have to react upon. Well, you decide, in fact, you don't have to react necessarily. On message, on open, on error, on close. And we also saw the add path param that allows you to work with templates. Some other stuff which I don't really talk here. Security, I've briefly mentioned that security is obviously part of WebSocket. Asynchronous, the WebSocket API support asynchronous capabilities. Protocol, I've briefly mentioned that you would have to write your own protocol, and there is not, I mean, so take your travel application, you will have to write your travel specific protocol. The only facility that is being provided by the WebSocket standard is the WebSocket standard has the notion of sub-protocols. It's basically some kind of tag that you can exchange during the connection. So I have my travel client that connects to my application, and the client can say, okay, I'm supporting the travel sub-protocol version 2. And the WebSocket backend side will then use that version of the protocol. Two consideration, firewalls. WebSocket are standard today. All browsers support WebSocket. Where you can expect to have some kind of issue or challenge is really on the infrastructure side. I mean, most of the firewalls today do support WebSocket, but a lot of them are configured so that they don't let WebSocket connection pass through. A few months ago, I was doing some tests on Microsoft Azure. Everything was working on my laptop. It wasn't on Azure. Why? Because at that time, Azure, so WebSocket were not supported on Azure. So if you are going into production with WebSocket, you need to be a good friend of the guy who manages the firewall. That's something to keep in mind. And finally, tools. So WebSocket is basically client-server, so we have a client WebSocket that is connecting to a WebSocket backend. So on the client side, we can have JavaScript. Backend side, we can have Java, and in between, we have a WebSocket protocol. So when something doesn't work, it's sometimes difficult to see what's going on. So clearly, you need to have some tools to do that. So being able to see what's happening on the network, to isolate, is it an issue on my client or on my backend side? So that's something which you need to use. So if you want to start with WebSocket, Java is, Glassfish 4, it has WebSocket support. And also, I encourage you to use Glassfish, because Glassfish has also some capabilities that will help you for WebSocket application. So I'm going to try to do a quick demo, which will be kind of challenging. So this is NetBeans 4. I have deployed one of the samples that is part of NetBeans 4. Don't look at the UI, it's very ugly. It's just to show you how things work. So this is basically a WebSocket-based drawing application. So if I do something here, you see that. So this is Chrome on the left side, and this is Firefox on the right side. So if I draw something here, you will see that it appears on the other side. And obviously, I can have 10 browsers connected to that WebSocket endpoint. They will all see the same drawing happening. So one of the features which is nice in NetBeans 7.4, you don't see, maybe you can't read it, but there is in Chrome there is a yellow message that says NetBeans connector is debugging this tab. So this is useful to see what's happening on the network. So if I go in NetBeans, I will clear this. I will just quickly reload. So this is really JavaScript code running in my Chrome. So you see that as soon as I hit reload, there is a new HTTP connection here. So I will zoom. So you can see. So this is NetBeans, in fact, and it has a live connection to the WebKit engine of Chrome. So I have a full visibility on the HTTP request which was done from the browser. So we see that it's indeed, it asks for a connection upgrade. We have my key, and this is what the response from the Glassfish instance. So it's indeed Glassfish 4, and it upgrades the connection. And this is the value which is computed based on the key which was sent away by the client. So this gives me visibility on what's happening in the network. And if I now start to send WebSocket message, we see that there is this new tab, frame. So it basically shows me all the WebSocket frames which are being exchanged. And so in this case, this is my protocol. It's a very basic protocol. So I'm defining which needs what figure needs to be drawn, the coordinates and the color. So if I go here, if I draw, let's say, a small square in yellow, if I draw them, oops, sorry, yeah, it's not easy. Okay, sorry. You will see that live, you have visibility on what's happening over the network. So this is really Chrome. We can use that. So from NetBeans, we can also do in-device debugging on iOS device. So we can see what's happening in the network. We also have within NetBeans JavaScript debugging capabilities. So we can debug from NetBeans this JavaScript code. And obviously, the backend side, so the Java EE code that is the server side of this WebSocket, we can obviously also debug it from NetBeans. So from NetBeans, we have really an end-to-end view, the client side, JavaScript, what's happening in the network, and we can also at the same time do debugging on the backend side. So, I will now conclude. So if you want to get started, well, NetBeans 7.4, which was released two days ago, I believe, has everything. So Glassfish, NetBeans, the Chrome debugger, and so on. If you want to know more, the Java 7 tutorial, and there is also a specific Java WebSocket books. It's one of the Java 7 books, which was written by the specification lead of WebSocket. So, with that, I would like to thank you, and I believe we have a few minutes for questions. Yes?
First question about clusters. When we have load balancer and cluster members, how it implements.
So the question is about the clustering, load balancing.
Yes.
So the clustering and load balancing itself is not part of the WebSocket specification, as is, well, it's not part of HTTP neither. So you can use front load balancer in front of WebSocket aware load balancer, but that's something you will have to handle by yourself.
What about JavaXB when you send XML? For example, I saw that we may send text to binary, just.
Yeah, but you can send XML over text. So you would have an encoders and a decoders that is using JAXB to do marshalling and unmarshalling. But in most of the cases, you would use JSON, I believe. Yes?
Is there any facility to register a new endpoint in runtime?
What do you mean by registering a new endpoint at runtime?
For example, I decided in runtime to create a new WebSocket URI.
No, that's so. Basically, you are changing the web app, so you need to redeploy the web app. That is a thing that. What you can do is you can kind of segment your WebSocket endpoint, so you can have different WebSocket. So within a web app, you can have different endpoints. The only thing you cannot have is those WebSocket needs to have different URI. But you can. So if let's say that you are starting your application with two endpoints, there's nothing that prevents you from deploying a new web app with a third endpoint.
But there are such facilities in Servlet API when we can, through Servlet config, register a new Servlet, a new URI.
But the Servlet API is version 3.1. This is version 1.0. That's the difference.
But those facilities comes from Servlet API 2.5.
But Servlet API is almost 15 years old. I mean, it's a very mature servlet, so it has a lot of capabilities. The WebSocket API, it's fresh new. So, but clearly, I mean, if you think that it makes sense, that's something you have to raise because that API will surely evolve. So maybe that's one of the features we have to address in upcoming release.
Okay, thank you.
You mentioned that during handshake the client and server exchange some security case. So does it mean that WebSocket is always secure?
No. So no, it's just to make sure that it's just an acknowledgement for the backend side that is talking to the right client side. It's not about it's not secure just with that.
Thank you. And the second question: is there some mapping between HTTP station and WebSocket session?
Yes, just for the handshake. The handshake is done over HTTP, so that means you have an HTTP session and so on. And once the protocol is being upgraded, you are not in the HTTP anymore. There was a question there.
Hello. If I'm sending a text message or a binary message, is there a possibility that on another side it will be fragmented and split into like 3 parts, like in regular sockets? Because this is where in regular sockets we have to manage this by ourselves.
No. If the endpoint sends it as a whole, it will be sent as a whole. So you will receive it as a whole. Yeah, that's guaranteed. Yeah.
Do you know statistics about percentage of users who have bad firewalls? Is it time now to use it in some commercial products?
Yeah. So the question, yeah. So I just raised that point because if you are starting with WebSocket, I'm pretty sure that you will be hit by that. But just to give you an indication, so WebSocket are supported in Glassfish 4. But WebSocket, I mean, now I'm taking my Oracle hat. WebLogic is supporting WebSocket, and OTD, which is our traffic shipping solutions, Oracle Traffic Director, is also WebSocket aware. So if we have such products which are not used typically in the open source world, but really by large customers such as banks and so on, so if those products support WebSocket, it's a sign that the market is really asking for WebSocket.
And about this tool in NetBeans, do you have any tools in different IDs?
You have to check with the IDE. Something that you can use, I think Chrome itself has a network monitor that is also WebSocket aware, so you can use it.
Yes,
but Wireshark is another solution to with what's happening on the network layer.
If I send checked messages over socket, they expect that all chunks will receive in the same order.
Yes.
Thank you.
Any more questions? Yeah, something I should mention before I take your question. The drawing application is just one of the samples we have in NetBeans. It's a great application to start because it has the Java backend code and the JavaScript code, but you won't use WebSocket to do such a basic drawing applications. Just want to.
Another question. Can you tell us more about message encoders and decoders life cycle? Are they thread safe or for each request instances in new one?
Let's see. So let's see. I would think so, but that's something I would have to check because I'm not sure. I think so. I think they are thread safe. So something I should mention also about encoders and decoder, they are instantiated as soon as the WebSocket is open. So it's not the first connection that will instantiate the encoders and decoders. It's really as soon as you are exposing your endpoint, they will be instantiated. But for thread safety, I think so, but I need to check.
Okay, this is the last question, I guess. Thank you for your speech. 5 minutes to change your